Welcome to madCAM for Jewelry. In this video I want to show you two scripts that I wrote that extend the madCAM functionality and something I find very useful for regular milling operations. Two scripts will be available attached with this video, and all you have to do is extract them to a folder of your choice and load them through Tools, Rhino script load command. So in this case you'll see that I have a few scripts loaded in this way. First script allows you to create a boundary curve around any object from a given C-plane. To give you a demonstration of this, let's say we have a ring like this, and I want to create a boundary curve for this top part of the ring. I could go through the steps of making a silhouette, performing curve Boolean operation, and then offsetting the curve to reflect my tapered bit by, let's say, 0.1 of a millimeter to get this usable boundary curve. Or I can just run the command, or rather the script. So all I have to do is go to Rhino script run, outline objects, select that object to outline, and there you go. The same outline has been created. The script works not just on your standard views on C-planes. You can create your own arbitrary C-plane through your perspective, for example, like so. And the same script will work exactly the same way, outlining the object, as you can see, from any given angle. The second script has to do with mirroring of toolpaths in madCAM, and that's something you may have already seen me do in a few of the other previous videos. It's a very useful piece of functionality that really perhaps ought to be a part of madCAM, a built-in functionality, but it's not. And to demonstrate this, I'm going to take one quadrant of this ring. So I took that boundary curve and just segmented it into 4 and selected just this 1/4. And I'm going to do curves from boundary, or rather toolpath from boundary curve calculation. So because we have the X and Y kind of quadruple symmetry here, there's really no reason to calculate this whole surface. We can do one quadrant and then mirror it over every which way. The problem is, if we use Rhino's basic tools, so mirror command, and we take this group and mirror it, let's say, over the y-axis, what you'll find is that instead of coming down and cutting from the top just like the original, this mirror toolpath will come down from the opposite part and come in from the underside of the ring. So let me show you this in the simulator. I'm just going to slow it right down so you can see the issue right away. And there you go. So an impossible scenario, and one that will cause you to either break your machine or the bit, the wax, or all of the above. So we don't want to do that. Now let's see what happens if we use our mirror toolpath script. We have to specify the toolpath triangle, which is entry point. We're prompted for another one because in some cases we have two of these, specifically in rotary toolpaths. In this case we don't have one of those, so just one will do, so we can press enter. And then, just like with a regular mirror command, mirror starting point and end point. You'll notice that the difference between the Rhino's command and this one is that both triangles are pointing the same way, which means the entry point for both of them will be from the same direction. So there you go, there's our first toolpath, and there's the mirror toolpath, both of which are calculated correctly. Likewise, you can continue to do this over the x-axis now. And you can even repeat it again here. to get the full quadruple symmetry in place. So one segment, the other one, third, and fourth. So very straightforward way to exploit the symmetry in your designs and reduce both your toolpath calculation time and the milling time. Once again, these scripts can be found in the description of the video below. And to install them, place them in your folder of choice, go into your Rhino scripts load, and click Add to specify the path. If you want these to be loaded every time you start Rhino, you can go to File, Properties, Rhino script, and specify the path to each script. Thanks for watching.